Hi, my name is David Larouche, and today I'll be presenting my electrical capstone project. The project I have created is an electronic safe with coin counting features. As shown in the pictures on the right, that's the final project constructed. So project outcomes, learning outcomes. So now I'm more confident with coding Arduino C language, from coding the safe interface and the coin slot. I also have more experience diagnosing, testing, and establishing DC circuits. New related problems: research on isolating Arduino grounds from sounds created by tasks running in a loop to prevent faulty interface response. Build a library for keypad or replace with a computer keypad for faster response. So these are related problems that have submerged throughout the construction of my project and things I could improve to make it response better. Own contribution. The biggest contribution I did for this project definitely has to be woodworking. Since my skills allowed me to mount devices and construct mechanisms with ease, it also let me build the safe with more security and maintenance features. Finally, field strength demonstrated. I would say overall engineering, as I designed two interfaces for both Arduinos and efficiently used the space I left to install components and mechanisms. I organized all aspects of the construction and tackled each task one after the other following my Gantt chart. These things prove that I'm dedicated, focused, and coordinated, which are all good traits to have in the electrical field. So this is the contents I'll be going over in my presentation. So first of all, controlled by two Arduino Mega 2560s. Then I'll be going over the comparisons of existing and own contributions, circuit diagram overview, safe construction, maintenance, wiring and devices, mechanisms, time management and milestones, flowchart, which I'll demonstrate the function of my project, and then finally the conclusion, which covers the recommendations. So the safe I constructed is controlled by two Arduino Mega 2560 boards. The reason why I use two of these boards is to promote loop relief. This enabled me to have reliable coin reading and use of the EPROM to print the LCD balance. Also, it enabled me to properly display the LED patterns functionality. So prior to separating the devices onto the two Arduinos, these two deliverables weren't acting as they should because the coin reading wasn't counting up correctly with the serial pulses for different coin values because the loop had too much stuff on it. And also the LED patterns weren't running properly because after each loop iteration, the pattern would stop while it wouldn't continue smoothly because there was too much on the loop, so the patterns wouldn't run properly. Alright, so on the first Arduino here, I have the 20x4 LCD and safe mode RGB for the safe interface. I have the 16x2 LCD to tell you to insert coins. I have a keypad so you can enter the 4-digit code. I have a servo and solenoid for the unlocking sequence. I have a speaker. And on the second Arduino, I have the 16x2 LCD, which shows you the added up coin balance once you unlock the safe. There's the coin scanner. There's the 3 coin activity RGBs, which flash blue once a coin has been read, which tells you that you can now enter a new coin without disrupting the last coin you entered. A push button to reset the balance to 0, LEDs for the patterns, potentiometer to switch through patterns 1 through 9, and finally an on-off switch and RGB that's either red or green depending on on-off situation of if you're using the LED patterns or not when the safe is unlocked. So now I'll be going over comparisons of different solutions I found to construct my project. So on the left you have the existing column and the right you have the own solution column. So first of all, for the coin scanning code, I ended up using an existing and own solution because I found a template of the coin scanning code online and I implemented it into my Arduino loop on a second Arduino, but I had to do my own solutions by changing the delay to make the coin reading efficient, and how to actually implement it in the code was all my own thought process to make it all work. And then there's the keypad response. So all of the existing solutions for that were matrix keypads, membrane keypads, and I tried all of these before doing my own solution, but there was too much of a big delay between pressing a button and getting the Arduino to read it. So I ended up building a custom keypad as shown in the pictures above. So this is the front of it. You see the 12 push buttons. This is the back of it. You see the proto board with the resistors for the voltage dividing push button circuits that have each their own resistor. And then you see the 12 wires going to the Arduino board, which are all digital inputs for the 12 buttons. And then another own solution of my own is the 4-digit password code. So because I didn't have a library for the keypad, since I made a custom one, I couldn't use any of the solutions online. And so this is why the 4-digit password code I created is unique and cannot be found online. Lastly, there's the safe shell built. It's built to allow for future deliverables. So because it's made of wood and there's still significant space left on the front of it and inside the actual construction, I'm able to easily cut out a part of the faceplate to add new deliverables, such as a fingerprint scanner or charger, anything I want basically. So I'm flexible for new deliverables. And lastly, there's the solenoid circuit. So I found a 12 volts DC circuit online, which was perfect for me because that's the solenoid I had. And after testing and checking the current and the voltage to make sure everything was reacting as it should, I found that this circuit was perfect for my situation, and this is why it's in the existing code. So circuit diagram overview. So we'll start with the legend and circuit references. So here you have DIO, AIO. This either means digital or analog input or output. And then here you have blue, which means, if you look at the actual schematic, anything that's over blue, so over here, 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 and here, it means that these devices are connected to the second Arduino. And then figure 1.1 shows the keypad circuit. So over here, down here, you have the actual physical soldering circuit that I did on the proto board, which was shown earlier over here. And then figure 2.1 shows the LED display circuit with its own proto board again, which has 8 digital outputs with 330 ohm resistors to have brightness, so that they're all the same brightness. And then for the actual schematic brief overview, you have the main power supply, which transforms 120 VAC to 24 VDC, and there's a 5 amp fuse at the output to protect my circuit because this power supply has 6 amps max output. And then you have a key lock, and that's the main on-off switch for my project. So when this key lock is closed, it gives power to the buck converter, and it turns on the green on LED on the side, which lets you know the safe is on. And here on the buck converter, you have 4 outputs, but I'm only using 3. So at 6 volts, I connected the servo, 12 volts connected the solenoid circuit and the coin slot. At 5 volts, I connected both Arduinos. So now to explain what's on the first Arduino, you have the 20x4 LCD with the interface, the safe mode RGB. Then you have the 16x2 LCD, which tells you to insert coins. You have the speaker. You have the keypad circuit, which we referred to figure 1.1 earlier, which was right here. And then you also have the solenoid circuit I said earlier and the servo. And you have the voltage dividing circuit that sends a signal to the second Arduino. And the second Arduino uses this to know that the safe is unlocked That way the loop can work as it should. And you have the LED mode RGB, you have the LED pattern switch, you have the balance reset push button, you have the patterns potentiometer, you have the LED display circuit, which referred to 2.1 earlier, right here. And then you also have the coin counter 3 RGBs listed over here, as well as the second 16:2 LCD, which displays the balance when the safe is unlocked. And that's basically the overall function of my circuit diagram. Safe construction. So I created my safe to allow for maintenance. So as can be seen in the picture on the right, there's the removable back piece which slides in and out. Once that piece is out, you can then take the top plexiglass piece out as needed. There's also a protoboard div switch to protect the Arduinos. So when you connect your Arduino to your computer to code, this div switch, once turned off, you can protect the protoboard and the buck converter from the voltage coming out of your PC. Moving on, the wiring and devices setup. So here at the right, you have the AC power cord coming in to supply the transformer, and then you have the adjusting potentiometer set to 24 VDC. You have the key lock main switch, which goes to the 5 amps fuse, and then goes to the main DC-DC buck converter. And then you have the first Arduino in the back here, and this second Arduino on the left here. These are mounted by Velcro, so if I ever need to take them out, it'll be easy. And in the back here, I mounted the protoboard. This protoboard connects all devices to the protoboard circuits, as well as the Arduino inputs and outputs. So mechanisms. So on the right here, you see the servo mechanism, as well as the solenoid mechanism. So here there's the door lock mechanism, which is connected by a thick gauge wire on the shaft of the servo, and when it turns clockwise or counterclockwise, this will lock or unlock the safe. And then here you see the solenoid wiring strapped going up into the hole with the servo wiring. This is so that the solenoid wiring won't go in the way of the servo mechanism. And here you see the magnetic contact of the door. So when this door is closed and the solenoid is activated, this contact will release the solenoid will push the door open. So finally, the coin fall and tray mechanism. So here you have the coin fall coming down from the coin slot. You have a cardboard protective piece to make sure the coins fall in the hole. You have a cardboard piece to push the coins into the tray. I installed red carpet at the bottom of the tray, just in the sole purpose of dimming the sound when the coins fall and to make it look nicer. So time management and milestones. So here you see a list of milestones I achieved throughout the construction and coding of my Capstone project. You see the relative dates and when they were achieved. So now I'll be going over the flowchart and project demonstration. So now we're here. We turn the main key switch on, which will start up the melody. So you enter the key, turn it on, can adjust the volume. So now the safe is on, the on LED is on. Let's say we enter the wrong password. And you press enter. So it stays locked. And the lock melody just played because the 4-digit code was entered incorrectly. So you return to locked. And in locked mode, you cannot use the LED patterns nor reset the LCD balance of your coins, but you can enter coins. So when the RGBs flash blue, it means you can now enter a new coin. Alright, so let's say you're ready to enter your password, but you start with the wrong digit. You can simply use the clear feature to restart entering the code. So now the correct code is 6789. So the password is ready to be entered. So right now we're going to enter the password correctly, which will start the correct melody and initiate the servo plus solenoid sequence, which will bring the safe to unlock mode. So with the code entered, press. So the door opens. You can now see your balance of 15 cents you entered earlier. And you can also get your coins. So now that the safe is unlocked, we can now reset the LCD balance and use the LED patterns. So since we entered 15 cents earlier, we can now reset it to 0. Now that it's reset to 0, I'll show the functioning of reading coins. So a nickel adds 5 cents, a dime, 10 cents, a quarter adds 25 cents, a dollar adds a dollar, finally a toonie adds $2, and now we can still reset this value. To use the LED patterns feature, you simply turn the switch to on. Once it is on, you can switch through the different settings. So first, we'll turn the LEDs on. And then patterns 1 through 9, you simply turn counterclockwise. So that's 1 through 4, it accelerates. Then you can go back. And turn it off when you're done. So now to lock the safe, you simply close the door held by a magnetic contact, and we will hold E for 5 beeps, which will play the lock melody and bring the safe back to lock mode. So E for 5 beeps. Let's remember the balance is at 25 cents. The safe is locking. So now we can turn the safe off. And let's say we come back to the safe. We re-enter the correct passcode. And we see the balance of 25 cents, which means that the EPROM is working as it should. To conclude, all project deliverables were accomplished to complete my project. Moving on, future recommendations. I would want to fix the 16:2 balance LCD since it flickers for some reason because of a busy loop or something in the code going on. Also, I would add a fingerprint scanner to add security to my project and a new unlocking feature. And lastly, I would want to implement a 4-digit password reset feature so that once the safe is unlocked, you're able to set the 4-digit code to a new code. And that's it. Thank you for listening.